So exercise number 3. Suppose that you can earn $16 per hour before taxes and can work up to 80 hours per week. Consider two income tax rates, 10% and 20%. Sub-exercise A. On the same diagram, draw the two weekly consumption leisure budget constraints reflecting the two different tax rates. Okay, so we will need a coordinate system again, which I will draw real quick. So on the x-axis, we have leisure measured in hours, and on the y-axis, we have weekly consumption. Weekly consumption. So in sub-exercise A, we were asked to draw two budget constraints. So the first one, let me just quickly shift this a little bit to this side here. So what we need to find out is the intercepts again. So for both budget constraints, we know that the leisure intercept, so the intercept on the x-axis is given by the maximum amount that leisure that an individual can enjoy per week, which is given by 80. Yes, so we know that an individual can work up to 80 hours per week. And then I guess the implicit assumption here is that in the rest of the time the person is sleeping. And now if the person is not working at all, the most amount of leisure that the person can enjoy per week is given by 80 hours. Now we need to find out about the two different y-intercepts of the budget constraint. So the first one for the 10% tax rate, so for 10% tax, is then simply given by the maximum working hour, so 80, times the wage that we're receiving, 16, multiplied with 1 minus the tax rate. The tax rate is 10%, so 1 minus 0.1, and hence we have 0.9. So we multiply this thing with 0.9. And if we calculate everything, we end up with $1,152. This will be the maximum weekly consumption of this person. So 1.152. And the second thing would be a 20% tax rate. Then we have a similar exercise. So we have 80 times 16 times 0.8, because we have a tax rate of 20%, and this is 1024. And we can draw it somewhere like here. And if we connect the respective y-intercept for each of the budget constraint with the x-intercept, we get two budget constraints, and I hope I can draw two straight lines here. Yes, this looks good. That's also fine, yes. So the first one is the budget constraint for 10%, and the second one is the budget constraint for 20%. And as you can see, if we increase the tax rate, the maximum weekly consumption measured in dollars is decreasing because of the tax rate, obviously. While leisure is not changing, because if you so the leisure intercept is not changing, because if you do not work at all, you do not pay taxes, so it doesn't matter how high the tax rate is. Okay, we will need this one coordinate system here for the rest of the sub exercises. We'll try to catch all of them. Okay, that's good. So in sub exercise B, in sub-exercise B, we are asked to draw a set of representative indifference curves such that the income effect of the tax increase outweighs the substitution effect. So if there is a tax increase, what basically happens is that for each amount of work that you choose, your real salary is decreasing because the taxes are increasing. Hence, for any amount of wage that you're receiving, you will have less real income left. And this is kind of a negative income effect on negative income effect on your consumption, your weekly consumption. But on the other hand, if taxes increase, it also means that leisure becomes relatively cheaper than than consuming because of the taxes, basically. So when you decide to work less in a situation where taxes increase, you basically give up less amount of weekly consumption because of a higher tax. Yeah, so you have kind of a substitution effect and an income effect when you increase the taxes. And depending on what type of a good leisure is, there might be kind of different reactions to the tax increase, in that we can have both situations where leisure is increasing, but at the same time, leisure could also be decreasing if it's a particular type of good. So yeah, let us go back. So we need the old coordinate system. Okay, somehow it didn't copy it. Just 1 second. Okay, so now let me make it a little bit bigger here. So I will erase some of the stuff that we do not need. So now we are supposed to draw an indifference curve such that the income effect of the tax increase outweighs the substitution effect. So I will try to like draw it clean, even though it's very difficult here. And if I do not kind of draw it perfectly, you can have a look in the solution PDF that I uploaded. There you will see more clean pictures. So if the income effect is outweighing the substitution effect, it means that we decrease leisure if there is a tax increase. Yeah, so even though leisure becomes relatively cheaper than consumption in this model, the income effect is so strong that we still and like reply to a decrease in the price of leisure by an increase of taxes by decreasing leisure and working even more. Yeah, and this is kind of the situation in which the income effect is outweighing the substitution effect. So the substitution effect would increase leisure, but here the income effect is decreasing leisure so strong that, yeah, higher taxes would lead to less leisure. Okay, so yeah, let me just draw it like this. So we would have 2 points. So let's say we have point 1 here. This is kind of the base situation. So we have an indifference curve which is kind of flat. So let me just try to draw it. Somehow like this, and then if we have an income effect which outweighs the substitution effect, then we would end up somewhere here if there is a tax increase. So the indifference curve then would be somewhere like here. It's actually looking not so bad. Okay, it should be, let me see if I can shift this. like this. Ah, yes, it's working actually. So, okay, it's not perfect, but now let's just assume that I draw it correctly. So what you would have is a movement in this direction due to the tax increase. Yeah. So even though leisure becomes relatively cheaper than consumption, and this would kind of lead to an increase in leisure instead of a decrease, the income effect due to the tax increase is so strong that the individual replies by increasing work time and decreasing leisure. Then we have a second case for which I will need what I drew before again. Let me see if it's still here. So this would be C. Let me just check real quick. Yes, it's still there. Very nice. Okay, let me just delete everything and then we can go to the exercise description. So in sub-exercise C, we're asked to draw a set of representative indifference curves such that the substitution effect of the tax increase outweighs the income effect. So now the question is, can we generate a situation where kind of if the taxes are increasing, so if the price of leisure is decreasing, do we reply with more leisure or not? And that's the question in the sub-exercise. So we're supposed to draw now basically the opposite case of what we had before. So we start from a point here, for instance, and we have an indifference curve which looks like, yeah, let's draw it somehow like this. Oh, wrong thing. Okay, this is also really bad, but let's try to draw it like this. And then we need a second indifference curve, which is here. Then let me just shift it, hopefully in a correct manner such that we can get the desired result. Yeah, let's say it's something somehow like this, even though again it's not a correct picture, but yeah, should give you a clear idea. So now what we have is that the price of leisure decreases due to the tax increase when going from this budget constraint here to this budget constraint. And as a consequence, since the price of leisure is decreasing, we reply to this by an increase of leisure. Yeah, so this would be a situation where leisure is actually a normal good and not an inferior good. Yeah, so if leisure is a normal good, what happens is that if the price of leisure is decreasing, then um, the amount of leisure in equilibrium should increase if the price is decreasing. Yeah, and this is what's happening here for those types of indifference curves. And yeah, here in this situation, the substitution effect due to the relative price change of leisure is stronger than the income effect, and hence the agent here replies by increasing leisure, hence working less. Okay, this brings us to exercise number 4, which will go into the direction of empirical, for an empirical question. So let's have a look. So suppose that you estimate the following female labor supply relationship. So the labor supply of an individual is equal to minus 320 plus 85 times the after tax wage plus 302 times a dummy, which indicates whether an individual is a college graduate or not. So it's either 0 or 1, minus 102 times a dummy, which indicates whether the female person is married or not. So again, it's either 0 or not. And labor supply is measured in annual hours worked, and the wages are expressed in hourly wages. In sub-exercise A, we are asked to interpret the coefficient on after-tax wages. So what does this coefficient imply about the effect? of increasing wages from $6 to $10 per hour on labor supply. Okay, so first of all, the coefficient is strictly positive. As a consequence, higher after tax wage increases labor supply. This is kind of this is a sign effect. So we know that since the coefficient is strictly positive, we know that if we increase, at least in this model, in this estimation, if we increase the after-tax wage, then the labor supply will also increase. But we can say a little bit more because we have a number there, not only a positive sign. The magnitude, or if you want to make a precise statement, for each dollar increase in after-tax wage, holding everything else constant, yeah, that's very important. So it's an isolated effect. So holding everything else constant, so for each dollar increase in after-tax wage, holding everything else constant, the labor supply increases by 85 hours per year. Therefore, a $4 increase, as we had it in the sub-exercise description, this means we have 4 times 85 equal to 340 hours increase of labor supply. Okay, so if we increase the after tax wage by $4, then females will reply by an increase of 340 hours of labor supply in a year. Sub-exercise B. What can we learn from this estimate about the income and substitution effects of wages on labor supply? So again, a little bit similar to the last exercise, if we increase, at least in this estimation here, after tax wages, what will basically happen is that we will have two effects. So first of all, if we increase the after tax wage, it increases our real income because our real income is always income in relation to the prices. And hence, if we increase the after tax wage, it simply means that our income is increasing and hence our real income is also increasing. On the other hand, if our after tax wage is increasing, it means that relatively the leisure will become relatively more expensive because for each unit of leisure that we consume, we give up more income because of the increase of the after tax wage. And hence there is kind of there is a income effect again as before, and then there is a substitution effect here. And what we can say is that in sum, it seems to be that the total effect is positive. So because of the coefficient being positive. So basically it means here that the income effect is if f offset by the substitution effect, and in this case. So any negative effect on labor supply due to the income effect is more than offset by the substitution effect. And this holds since the coefficient is positive. So all that we can say is that the total effect is positive. So it must be the case that the negative effect due to an income effect, so now it's flipped around. So if we decrease the after-tax wage is offset, so it's more than offset by the substitution effect because labor supply is actually increasing if we increase after-tax wage. Yeah, and we cannot make any other statements here. So we cannot decompose the effect to know the exact magnitudes of the income effect and the substitution effect here on labor supply, because we simply have only this after-tax wage estimation here. But we can only say that the sum of the two effects is always positive. So just to finish it, but we cannot measure the exact magnitudes of the income and the substitution effect. And this finishes sub-exercise B and brings us to C. So in sub-exercise C, we are asked like a typical question which you will encounter if you're doing empirical work. And the question is there some bias in the estimation? So in particular, it is asked whether the coefficient for after-tax wage could be bias. And we are asked to give examples. So typically, there are many different types of biasness of an estimation. So what we will consider here is the so-called omitted variable bias. So the omitted, I think it's written like this. I'm not sure. Let me just check to be sure. 1 second. Yeah, of course it was wrong. It's the omitted, it's written like this. It's the omitted variable bias. So omitted variable bias basically means that within the equation which defined, so the estimation equation, which related labor supply to after tax wage and some other components. There could be some variables which we did not put into this equation, which might both affect labor supply and after tax wages. And therefore, if we do not put them into this estimation, what might happen is that we over or underestimate the effect of after tax wage on labor supply, because the changes in labor supply due to the after tax wage might actually be due to some uncontrolled or unmeasured variables which we did not include in this estimation here. Yeah, so that's the typical problem with the omitted variable bias. And one example, so I will stick to one example. So one example for this particular example here is, for instance, family size or family size or children dummy. So family size or children dummy would basically, yeah, those two things here would be variables which you could potentially, so you're able to measure the family size, and you're also able to measure whether a family has children or not. So the two here are quite related. And the thing is that, for instance, children, so or family size, or let's say, I think children is a little bit more, um, it's a nicer example. So children appearance might have an effect on both labor supply and on after tax wage. So why could it have an effect on labor supply? Well, if at least in old times, if if females were married, and yeah, the couple or the married couple became parents, then typically females would stay home, or even today, most of the times it's the women which stay home. So the female would stay home, and as a consequence, this would affect the labor supply per hour. So it would decrease. So the presence of children would decrease labor supply, and at the same time, the presence of children also, since it's decreasing labor supply, it's also decreasing after tax wages, because you could imagine that your after tax wage is a function of experience, work experience that you have, and at the same time, work experience that you have depends on whether you're taking a break or not when you're getting children, and hence this kind of, yep, this dummy, which kind of measures whether you have children or not, might have an impact on both the after tax wage due to experience and labor supply due to, yeah, providing childcare from the mother. Yeah, and this could bias the results in that it could kind of overestimate the effect of after tax wages on labor supply. Yeah, so if we would write it down in a compact way, what would we write? So we could write that um, amount of children or number of children affects after tax wage by yielding, or by, for instance, parental leave. Same holds for labor supply. Yeah, and if you do not measure or do not control for the number of children, for instance, in this estimation equation, you might get a biased estimation. And this is one of the reasons, yeah, why this coefficient could be biased, and it's actually not a causal effect that we measure here. In that, if we really increase after-tax wages by $1, that the increase in labor supply would be 85. It could be less or more depending on what type of emitted variable bias we have. And this finishes question number 4.